This is the lesson for Chapter 11, Section 4, titled Adding and Subtracting Rational Expressions. And so let's take a look at our first few problems today, and we're going to end up seeing that the first few problems already have the common denominator, and that's what we need when we're dealing with addition or subtraction with fractions. We need the denominators the same, and that's what we'll see here. So all we have to do is add the fractions, add the numerators together. So you're just collecting like terms, and so I'm going to rewrite this as 5c plus c minus 28, and it's all over that same denominator of 2c plus 7. Well, I can collect the two c terms here, and that leaves me with 6c minus 28. And down below I'll have this 2c plus 7. So now what I want to do is take out a common factor to see if I can do any reducing. And so I see that the common factor between these two terms is just going to be 2. So when I do that, I pull out the 2, and that'd leave me with a 3c minus 14. And I do not have any other factors that I can take out from these two terms, so I cannot do any canceling in this case here. So that would be my answer. So I can also leave it in this term, in this expression here, as the 6c minus 28 all over the 2c plus 7. So that would be another possible way of writing that solution. Taking a look at the next problem. Whenever we have subtraction, you always want to change it to an addition problem. So I'm going to add the opposite. And the key is, especially when you have more than one term, you got to take the opposite of all of these terms. In this case, there's just one term, so just taking the opposite of 4, which is negative 4. So I collect these two terms together. That leaves me with negative 3 over 2 minus b. See, the only thing I would do on this one is I would just take out that negative 1. Do the same thing here. Divide each of these terms by negative 1. So you've got negative 1 times 3 over, and then negative 1 times by, and then these two terms will switch signs. So positive b minus 2. And then you'll see these negative 1's canceling out. So what I'm left with is 3 over b minus 2, and that would be a simplified form. On this next one, same thing. I'm adding the opposite, so I'm going to treat this as 2t minus 3 all over that same denominator of 2t squared minus t minus 3. Now what you always want to do, though, with adding and subtracting, there might not be as much canceling as with the division and the multiplication, so look for common factors as we go. So I don't see any common factors with the numerator, and no common factors down below, but it is a trinomial, so it might end up factoring as two binomials. Let's check and see if it does. 2t and t. Now to get a numbers that multiply to make 3, I'm going to try 3 here and a 1 here. That'll work because this is 2t right here, this is 3t, and those will subtract to make negative 1 if I make the minus sign right there and put the plus sign right here. And look, we've got some canceling that we can now do. See, the 2t minus 3's will cancel. Now when we do that, and everything's gone up top, remember, you actually have a 1 on top. When things cancel, they make 1's. So we've got 1 over t plus 1 is our answer. So moving on to the next type of problem, these ones do not have the same denominator. And so the key on this one is to, first thing I would do before I did anything is change it to an addition problem. So I'm going to add the opposite there. And then now I'm going to go ahead and multiply by the other's denominator. So d plus 2 over d plus 2. And on this side, I'm going to multiply by d minus 1 over d minus 1. And so when I do that, I distribute the 3 over both these terms. That leaves me with 3d plus 6. You've got to do that distribution because we're going to want to collect terms afterwards. So do the same thing here. Negative 2d, and then a plus 2. This was a 6 right here. And then down below we have the two factors. And now don't multiply it out. Leave them as factors. So d minus 1, d plus 2. The reason is that if we were to collect these like terms and then factor, there might be some reducing that could happen. So we'll go ahead and see if that's the case. 3d minus 2d makes 1d. 6 plus 2 leaves me with 8. And so I have d plus 8 all over d minus 1 times by d plus 2. And that's it. That's as far as I can really take the problem. There's no canceling that can occur because the factors are not the same. So in this one, we do the same sort of thing. We're going to multiply this term here by an expression that by factors this one does not have. So for instance here, I need to multiply this side by a 3 over 3. This side needs a 7y squared over 7y squared. And so what I've got left here is 9 over, now go ahead and multiply these numbers together, 21y to the 4th, and then plus 14y squared over 21y to the 4th power. And so I can't combine the 9 and the 14y squared as one number, so I leave them as separate factors. 14y squared plus 9 all over 21y squared, or y to the 4th power. And that's it. That's as far as I can take the problem. There's no common factors, so we're done there. I do want to go over one more problem. And in this situation, I want to have one where we've got more than one term in the numerator that needs to switch signs. So for instance, on this one here, let's say it was 1 minus m all over an m minus 4, and then minus, and then we've got negative 2m plus 1 all over m plus 4. So the m minus 4 and the m plus 4 look pretty much the same, but they're not because of the signs between the 4's. So before I go ahead and come up with a common denominator, I really need to add the opposite first, otherwise I might make some errors. So I'm going to add the opposite here, change subtraction to addition. Next, this expression here up on top, all the signs need to switch. So this negative 2m, change to a positive. The positive 1, change to a negative. Now I'm ready to go ahead and multiply by the other denominators, the other fractions denominator. So it's going to be an m plus 4 over m plus 4 on this side. This side needs a m minus 4 over an m minus 4. And I go ahead and do the work. So when I do the work, it's just using FOIL. So I'm going to rewrite this one here as negative m plus 1. It'll be easier when you're using the FOIL method to have them in descending order. And so m times m makes, it's going to make a negative m squared. This will make a 1m, negative 4m makes negative 3m. 4 and 1 make 4. Do the same thing. Now don't worry about the denominators. It's all going to be over the same denominator. M plus 4, m minus 4. So I just write as one big fraction right now. And then do the same thing here. You're going to multiply 2m times m makes 2m squared. So positive 2m squared. And then 2m times negative 4 makes negative 8. This makes a negative 1. So that makes negative 9m. And then negative 1, negative 4 make a positive 4. So now we have to collect like terms. So we have 1m squared, and then negative 3, negative 12 makes a negative 12m. 4 and 4 make a positive 8. And so there we have it. So now down below we've got an m plus 4 and a m minus 4. Now what I want to do is to see if this factors at all. And so when I look at it, looking at numbers that multiply to make 8 would be like 4 and 2, and I can't get those to add to make 12. And the other number that would make it, that would add to numbers that would make it larger would be 8 and 1. That would only add to 9, so I can't factor this any further. So this is as far as I could take the problem. So those are the types of problems we're going to see on tonight's assignment. Good luck.